derivatives represent a value, so when it's still like if. Like
Now, watch. Keep going. What's the derivative? That.
Yes.
So this is a part of du. So I can't put a u here because I need it there to become du. What am I? What is it that I'm missing?
Technically, that's also equal to u.
Sure. Why not? Sure. But it's a part of du, which is more important. So these functions whose derivatives have them back in it, they make for easy mistakes on integration. Because like you said, it seems like I put a u there, but then that screws my du over. My du doesn't make any damn sense anymore. So that can't be the one that I let u be u. That must be the one that's in du. So this would, I'm missing a 2 here.
2 and 1 over 2. 1.
Because that would make overall 1. So that means I didn't do anything, right? Okay. So then I get 2 integral sine u. And then this is d. So that's when you have a repeated function like that, that's what determines, well, which one do you need for the du? That, you better not touch that one then. That's where u goes. Cool. So let's do number, 6. Because I don't have that one on the answer key, and then I'll give you guys the answer. So I tell you that f of x is this business. So there's a couple things to be careful of. One of them I need to take care of immediately. Yeah, the limits are in the wrong place, right?
So it's negative.
Now in the process of doing this derivative, what do I have to be careful about?
You have to.
What's the inside function?
X squared.
X squared. Again, this is nothing. This is crap. This is nothing. The function is the area under this thing. Right? So this has nothing to do with the function at all. My inside function is x squared. What's inside the integral? I know this is inside the integral. So when I talk about an area function, that defines inside the function, right? Right there. So what's inside this? X squared. Which means when I take the derivative, I'm going to have to use chain rule. The inside thing is not just x, it's x squared. So it's got to get a term. So the derivative of an integral is that thing evaluated where?
X squared.
Yeah. Times 2x. Chain rule doesn't care. It's like, oh, that's nice for you. You're an integral. I don't care. The inside thing is not just x. You got to multiply by its derivative. Always. I don't care what it is you're differentiating.
And then the 5 in terms of constant go away.
Yeah, it did that. Yeah, it did that already. No, I never take an integral. I don't. Because I'm taking the derivative, so I'm not going to. It's sort of like, take 8, now add 5, now subtract 5. I'm not going to add 5 in the first damn place. Because you just told me to subtract. So I'm not integrating, but if I did, that part would be constant. That's why it doesn't show up here. I like it. Now some of you guys might be tempted to do something with this. You just got to be careful if you want to. This would be negative 2x secant of absolute value of x. Oh, yeah. Square root of x squared is not x. Because x could be negative. So I've got to force it to be positive if you want to replace it. Like, why is there no plus c? Good, I took a derivative. I'm not integrating. I took a derivative. There's no plus c with it in derivatives. There's no plus c. There's no plus c in derivatives. Sorry. League of their own? No? Okay. Crying, baseball. There is crying in calculus. I know all too well. It's one of the worst things in the world for teachers to make a student cry, and I've done that before. You guys like, you might do it again. I'll give you little plops as I grade too, we'll see. Yeah. So anything else? What? Oh, let me give you guys the answer key. I got, these are, let's see how many of these I got. These are all stable and nice because they're the ones I had left over from last semester.
Technically, you might need
What's that?
You could leave the X squared in and your squared.
Yeah, you can make it square root of x squared stop and leave it there, yeah.
Just all the little things in there.
You want good weight? And one for you want good.
What do we got there?
First one is that down long. Second one is on the
No, it's not. That's why you get both of them. Wait. Oh yeah, let me explain. Hold on. There's a little bit of catalog time. All right. Let me see if you guys can handle this. I don't know. All right. So, last semester I only gave 4 tests. That's why I said practice test 4. So, like number 1 on the answer key does not exist on yours because that was on our last test. All right. So, what does that mean about what it says number 2 on the answer key is actually number 1 for us? Crazy. No, go with me now. Wait, you gotta stay with it. So 3 is actually 2. Now here's the neat thing. 4 is 4 because I didn't have a number 3 in there.
What's confusion?
Right, because look at the original. Is there a number 3 in the original? No, so it catches up. I like it.
That's pretty mind-blowing.
That's too bad. So that's, trying to Frankenstein last semester's 4 tests into our semester's answer keys. That's just the way it goes.
So 2 is 1 and 3.
Can you do the user
You have to.
I can probably look it up on YouTube, but I always forget.
I do it with my Calc 2 students because that's where we learn the math we need. We don't know Taylor polynomials yet. We don't know infinite sums to create functions yet, and that's what you need. I mean, that is a singular thing. But e to the pi I, like e to the pi I means rotate by 180 degrees. So e to the pi over 2I means rotate by 90 degrees. So if I rotate, so this is not a proof, but if I rotate by 180 degrees, where do I end up? -1. So e to the pi I is -1, plus 1 is 0. So saying it like that, it loses some of its magic. But the idea that e to the pi I somehow means a rotation, that's the neat part. That's the part like, what the shit is that? So we don't know enough math for me to show you that. Yeah. Anyway, so that's a little teaser for Calc 2. If you want to know the full story behind that, take Calc 2.
I'm just thinking about that part.
We got like 2 minutes left. Anything else you want to talk about? I will be in my office probably by like 11 on Monday if you want to come by.
Do 5.4 number 6.
What's that?
5.4 number 6.
Okay. So when I'm integrating radicals, the first thing I should do is what?
Oh, make it to a power.
Yeah. Oh, it's not as bad as I thought. I could have squared this whole thing. That would have been even better. So I can rewrite this as the integral of.
X to the 1/3.
3 halves.
3 halves.
4 times to the 2/3. Dx.
What's in the bottom of plants? Root. So the root goes on the bottom. Power is all powerful, so it goes on top. Power 3, root 2, 3 halves. Power 2, root 3, 2/3.
Easy stuff.
Yes, easy. But you make a mistake on this step, you're screwed for the rest of it, right? So now it's easy, right? It should be. Now it comes x to the 3 plus 2 is 5 halves. 2/5. 2 plus 3 is 5 over 3. 3/5. Plus write the power and then the number out front. That makes it easy because you just flip the power to put it up front. Makes it easy. I love it when everybody's just like, I just want to wait in case somebody asks something. You're all just looking at me and I'm like, I got nothing. I got nothing.
We did 5, 4, and 50. Well, let's see if it gets harder. I'm on indefinite.
Infinity.
Yeah. There's no extra test.
Oh, okay. So they want you to integrate along the y-axis, is what they're telling you to do, right? So find the area of this region by writing x as a function of y and integrating with respect to y. Because they want to find this area. So if I integrated from 0 to this on the x-axis, I would get the wrong area. I'd get the area below this. Do you see what I'm saying? So they're saying if the area you want is actually in relation to the y-axis, you better integrate along the y-axis. So what would it be integral from what to what?
0 to 1.
That I know already. But what am I integrating? What do I need this to be? Because this is going to be dy. So I have to do what with this? So this will be x equals
Y to the fourth.
y to the fourth? Yeah. And now it's easy.
That's right. Was the y equals 1 boundary, was that part of the problem?
Yeah.
Can you finish that?
What do you get?
Plus C.
So you get 1/5, right? Now, real quick. What would this be? This is kind of neat. What would this be? It's where 1 and 4th root of x equals y equal. Where's this equal 1? When x is 1. Okay, good. What's the area of that square? Alright, that's crazy. The area of the square is 1. So if I find the area underneath here, I just have to subtract it from 1 to get that. So that would be integral from 0 to 1 on the x-axis, and then I can leave this guy alone. I better get the same damn answer I got here by doing it this other way. So what's the integral of x to the 1/4? 0 to 1. Plug a 1 in, you get 4/5. Subtract that from the 1 area, you get freaking 1/5. Of course you do. If you find this area, subtract it from the whole area, you end up with the area they want. That's neat. Totally trippy. So this integral finds this area. That's why the problem wanted you to do this. But we could have just gotten the whole area, done that, and subtracted to get the area they wanted. That's the other way to do that.
So everything's two-dimensional unless they say revolving around.
Exactly. Unless they say revolve, it's 2D. I like it. Rotate around something. Yeah.
Cool. At the end of the last step, you plug in 1 and it subtracted the plug-in of 0. It was 0, so it didn't have
Yeah. Polynomials are awesome. If 0 is one of the limits for a polynomial, I don't have to worry about it.
Okay.
Unless there's a...
It's the top one's plugged in minus the bottom one plugged in?
Totally, yes. F of B minus F of A.
Okay.
Think we're good?
I think I'm good.
It's time, anyway.
It's time.
It is time.
I have 3 more questions.
I have no more answers. I'm all out of answers.
We're waiting for
I'm here to give ass kickings and answers, and I'm all out of answers.
So,
The difference